Okay, so in this question we're asked, is the function 3x minus 3 onto, so is it injective? And we're told that our domain and our range is any real number. So we can see that this is a linear graph, and any linear graph will always be an injective function. So if I was going to sketch this, so I can see it would cross the y at minus 3, it would cross the x at 1 from doing 3x minus 3 equal to 0. So I can see there, so every input that I have will have one specific output. So that means it is an injective onto function. Okay, in this one, so we have the modulus of x plus 1. Again, our input, our domain is any real number, and our range is any real number. Okay, so doing a sketch of this. So for x plus 1 equal to 0, that would be x is equal to minus 1. And then I could also see if I was doing y is equal to x plus 1 and leaving x equal to 0, I'd have y is equal to 1. So then that would cross at 1 here, and then minus 1. So if I was just sketching x plus 1, it would be like this. But seeing as it's the modulus, I then disregard the negative part. So where it hits the x-axis, that'll rebound back up at point 1 here, and I'm going to get rid of all the negative part now. So I don't need that. Okay, so let's just fill in again. So that was minus 1, and I might as well keep the same color, so let me just make that black as well there. Okay, so there is my graph, or the modulus of x plus 1. So we need to see now, is this an onto function? So that means for every input there's one specific output. Okay, so for, let's say I have a point here, I'm going up here. Okay, and I can see it. I have an output here, but that would also be the same output over here if I had an input of there. So you can see two inputs there will have the same output. So because of that, that means this is not an injective function. It's not onto. Remember, to be onto, every output has a unique input. But you can see in this one, I have two inputs have the same output. Also, the range of this question is any real number. But I can see, because it's a modulus function, I can only have positive values for an output. So all the negative numbers down here, I can never get them. So that's another reason why it cannot be an injective function. Okay, so the next one here, so we need to show that this function, so x cubed minus 2, is a bijection. Okay, so I'll do this by doing a sketch. So I can see it's positive cubic, so it'll have this shape, and it's going to cross the y-axis then at minus 2. Okay, so the graph will just look like that. Now, I'm asked here to show that it's a bijection function. So, and again, my input is any real number, the output is any real number, and I can see for this that for every input, I am going to have an output. Okay, you can see there, anything I put in for my input, I'm going to have an output. And as well, okay, I can put in any real number, and then I'll also have an output of any real number. So I can see there from the graph that this is a bijection function. Okay, in this one here now, we need to show that the graph of 3x squared is not a bijection, and our input, our domain, is any real number, and our range is also any real number. Okay, so the graph of this, so I can see it's going to be quadratic like this, and it's just going to cross here at 0. So there's my graph. And now I can see straight away from looking at this graph that I can only have positive values. I can't have any negative values. So anything of my input, okay, will always have a positive output. So to show that it's not a bijection, okay, I could just say not bijection as only has positive outputs. Okay, so anything you put in, you'll always have a positive output. So that means all the negative real numbers are not catered for, so that is not a bijection.